Hello guys, this is Muhammad Aslam currently doing a data science intern in Oasis infobyte. I have assigned with some tasks, that is some 5 tasks that I have assigned with. So today I'm going to explain each and every task that I've did on this internship period, right? So let's get into it. So first task that it has given for me is iris flower classification. So what is this iris flower in the sense? Basically, generally it's a flower and it has a three varieties, that is setosa, versicolor, and virginica. So it differs according to the petal length, petal width, and petal length. So these are some major four features are differentiating these three categories. So let's see the code. So I have used the necessary inbuilt function for this necessary inbuilt function to do the pre-processing works. That is, I have loaded the CSV file to analyze this data. Describe. So what is this describe function will do is that this function is used to give a 5 number summary for each and every column. As you can see, a sepal length column has a 5 number summary, mean, standard deviation. This 25% is nothing but a quartile 1, median, quartile 3, so maximum value. So describe function is used to describe each and every feature of your column, right? And then we are separating the feature and class value. So these four feature will be separated into x, and remaining the class value will be separated as y. So as you can see, the class value is separated in the form of array. Then we are using the train test split. So what this module do? This module used to split the data for test and train according to the give specified size. This size is nothing but percentage of split has to be done. Okay. Then we are using support vector machine. So what this support vector machine will do? The support vector machine is nothing but a generally a classification algorithm that separates the data points with the help of margins. Margin in the sense it's a line separating the classes. Here I have used the kernel based support vector machine that separates, because the support vector machine only can do binary classification. The kernel based support vector machine can handle the multiple class values. Okay, and then I'm giving the model, giving the training data to this model and creating the support vector model, and then I'm feeding the test data to predict from the trained model. So and then I'm calculating the accuracy score and the classification report. This is the first task that I have given assigned for me. Now let's move into the second task. The second task is nothing but unemployment analysis. What is unemployment analysis? Due to COVID, the unemployment taken place right in India. All the people have lost their jobs. So we have to analyze that using the given data set that I have downloaded from Kaggle. It's we can download the data set from by clicking this link. It will directly redirect to the Kaggle. So let's get into the second task. So what the second task is? So as you can see, the same necessary modules has been imported and reading the CSV file and checking the columns is null or not. What you are doing here is checking the null values present in the column. So as you can see, there is no null value because since it's download from the Kaggle, it has highly pre-processed and it don't have much missing values. So zero null values, and then we are taking the list of columns. So list of columns in the sense the data dot columns will return the column names of the given data. Okay, and then yes, we are just printing it as usual. And heat map, what this heat map is used to do is it will print a correlation matrix. As you can see, I have fed dot core, which nothing but a how each and every column is related to each other, how each and every value influence each other, right? So generally the correlation is nothing but how the car price depend on the some major features like mileage, horsepower it can produce. So these are some well-known features. Generally when you are going to buy a car, you will see some major things, right? How this car performs, how much that does it cost, whether this car is good for me, good suit for me. That kind of things we are doing here. The car price prediction with machine learning is nothing but a predicting the price based on its mileage and things that mileage, car horsepower. Okay, let's see the code first. Yeah, as you can see the things, the general things that we are doing: importing the necessary CSV files and reading that CSV file, taking the columns, and we are changing those column values, because whenever we are not changing those column values, what we are doing is we are just removing the car ID, nothing but this car ID 1 2 3 4 additional column values, right? So we are just removing it and taking it an X value, and then we are taking Y value separately, label encoder. So here's the thing that you are doing. So what this label encoder does is it converts the text data, in the sense these are the categorical data, right? STD, standard turbo, gas. So in the check for the fuel type, gas, diesel, petrol. So this might be the range of fuel type value that could be take place. So, okay, so we are just converting the string representation into number factors. In the simple case, if the fuel type has a three categories, such as gas type is equal to fuel type is equal to gas, diesel, petrol, it will automatically assigns 0 1 2 for the column values, like it assigning the factor variables based on numbers. So that's what the label encoder do. So that's what we are doing. As you can see, after printing it, you can see that the fuel type has an diesel and gas. So comparing with 0 is an diesel, 1 is an gas value, that kind of it will convert it, that string representation of factor to number representation of factors. That's the label and work of the label encoder, right? And then as you can see, we are just scaling. So 0 1, we are just scaling the value. Why we are scaling it? Because when we are feeding to a regression model, predicting a price is nothing but a regression model, regressive type of machine learning. So when you are feeding for a regressive model, you cannot give just 0 1, so it won't be useful, it won't be a useful prediction. So when we are giving to a regression model, you should do a scaling, either standard scalar or min max scalar. So preferably standard scalar gives a more accuracy than the min max scalar. So I'm just going with standard scalar and scale the values, and again that same test train split, I'm feeding it to an regression model and then predicting the prices, right? As you can see, the price has been predicted here. So the actual price will be here. Where is that actual? We don't have a price. Okay, we don't have price column here, but we have predicted the price for based on that particular value. The mean square error. So it gives the it what the mean square error does is it gives the how model perform. It talks about the model performance. Okay, it evaluates the model performance. That's a simple thing the mean square error do. It's generally used for regressive models. Okay, and then stats model API. So what this give? It gives the statistical reports. Okay, statistical report, the coefficient, standard error, t-value, the t-value based on the hypothesis, the t-value will be taken. The comparing the t-value with p-value. As you can, if you have studied the statistics, the null hypothesis and alternate hypothesis, you will understand what these things are doing with. So that's the thing here. So let's move on to task 4, email spam detection. So as you can see, the what is the main thing here is whenever the advertisements that are sending into an email, it might be tempting and made you to click that advertisement, and some important informations will be gathered by some the hackers or somebody who is sent that mail, right? So if in the mail section, as you can see the spam, you can see that spam. What's the spam? In the sense it separates the mail that is useful for the user, in the sense it is the correct mail that doesn't harm you, the user doesn't harm the user. So that kind of mail will be separated from the spam mails. So that's a general thing we are doing in the email spam detection. So as you can see in the email spam detection, you are given with some text, you are given with some data that is actually why this is an NaN value is it's sent by some users, so it has some null value, so we have to handle it properly. So this CSV file contains some spamful contents. This contents will be spam. Okay, this contents are spam that we have to make make our model to understand these kind. If these kind of text comes, if these kind of possibilities of text comes, we have to make our model to categorize themselves as a spam. Okay, as you can see, I have imported the spam.csv, and I'm splitting that value from that column only category, and you can see ham spam. So this is a class value and this is a text value. We have to remove this null value, so that we have doing here. So okay, describe. So again, as you can see, this describe function returns the number of not harmful messages and spam messages, and frequency of these each messages. And then as you can see, we are doing the same label encoding process here, and we are encoding the class values into 0 1, and message will be kept here, and doing the test time split, and doing the count vectorizer. So what it does is that count vectorizers, what this count vector wait just me sorry, it converts the text, that count vector is what it will do, it converts the text values into numerical values. Okay, that what this count vectorizer do for for machine learning training. So this will do that same thing. And the multinomial NB, so as you can see, the Gaussian NB, binomial NB, it's a type of a naive Bayes that we are using for prediction. As you can see, this spam detection has this model gives an accuracy of 98.92, so that's well good accuracy for a model. So if I run this, wait just for a minute. So if something, let's take this spam thing. Okay, copy it, paste. Yeah, it's spam, it came as a spam, right? So it then try to give a non-spam mail. Hello, I am Aslam. So this is a not spam. So this is what this thing do. So okay, let's move on to other task 5, the sales prediction. So based on the people interest, whether the people will buy or not a particular product, that's what this task is about. So we're just predicting. Again, it deals with a regression. Okay, whenever you're talking about predicting a sales, predicting a things, it always deals with a regression. So as you can see, I have used the linear regression model, right? So let's start from the first. So what this dataset actually contains, it is about the advertisement that the company has spent to publicity the product. So the product number 0, we have to remove this column first, and the unnamed 0, right? So that we are doing here, and we are taking the values, separating the class values and that values. Okay, the sales, as you can see, whenever we are doing a promotion through TV, 23.0%, 37.8, 6.2, you will get a sales of 22.1%. So that's the thing, we are separating the features and columns. Again, the same things we are doing. So we are just comparing with the class value. So whenever you are doing something on TV, how much sales got increased. So this is thing kind of a correlation we are just plotting the graph. Okay, and then we are scaling. As you can see, whenever you are feeding to an uh, regression model, you should scale the data in order to get a good accuracy. And we are doing the train test split, and we are predicting the sales. And the model performance, it has a least mean squared errors. That means this model has a very good performance. And again, the statistical reports that we have written. So that's the 5 tasks that I have given for me. I have completed it. So thank you for this opportunity, Oasis Infobyte. It's very learning. It's a kind of a good learning process and being in this. Thank you so much.